Hello, we are Whale Power, and this is how we use the design cycle to create a fountain.
Before we even started our project, we had to read up on our design specifications. They were two. First, water had to flow up against gravity without tubing for at least 1 inch. Second, we could choose between three choices. One, include an actuator, which the flow from the water would turn on some light, sound, or create some movement. Second, have a mechanical, not an electric pump. Or third, use laminar flow, which is smooth, uninterrupted flow. We chose to go with the first optional one, which is included an actuator, our fidget spinner.
The first part of the design cycle is ask, so we asked how we could create a fountain that moves water against gravity and actuates some kind of movement. To start out, we did some research.
The next part of the design cycle is imagine. During our first few meetings, we brainstormed a few ideas for our water fountain. Some of the ideas that we discussed were creating a fruit basket, an NC State themed fountain, and finally we came across the idea of a whale. After much deliberation, Whale Power became the team name, after our design.
The next part of the cycle was planning. We knew we would need a whale, so we contacted the craft center to start our work on the centerpiece of the fountain. Additionally, we needed a basin, so we decided to follow the underwater theme with a fish tank. Other materials we needed included a pump and tubing.
Finally, it was time to start creating. We made 4 clay whale prototypes. Then we fired and glazed them. We put together the basic components of our fountain: the pump, the tubing, and the tank. Our first test led us to realize that the pump had a much higher flow rate than necessary. This was our first design challenge.
The next step in the cycle was improve. Our first improvement was controlling the water pressure. We first tested a clamp, which worked, but it was not aesthetically pleasing. Next, we tested a splitter, which worked out much better, so we used it in our final product. Then we added our actuator component, the fidget spinner. Once we had the final design, we decorated the fountain with stones, plants, and fish.
This was our final product shown at FED. We placed 9th out of 15.
Although we were happy with how our project turned out, if we had to change something, we would design a different actuator instead of the fidget spinner we put. We originally focused more on the functional part of the fountain and didn't leave enough time to design a more creative and advanced actuator that fit the aquatic theme.
So here's a few pieces of advice we'd give for incoming freshmen in engineering. So one thing that I'm really grateful for is the fact that we started early. At the beginning of the project, it seemed like really hard and just kind of impossible, because here we were, 4 freshman engineering students who had really not much experience with doing any of this. And I thought it was going to be really hard for us to finish it. But one thing that I'm really grateful for is that we broke the project up into bite-sized pieces. The first week we got our group assignments, we met and we talked about our potential designs. So then as we went through the project and as we went through the semester, each task seemed easier than it would be if we had waited till the end to do all of it.
The best piece of advice I can think of for new engineering groups is that, at least in the beginning, simpler is almost always better. So what I mean by that is that you should build a proof of concept, your minimum viable product that works well, and then you should add details. So for us, that was just getting our fish tank and our pump, filling it with water and making sure the pump worked well. After that, we built our whale, put that on top of the pump, and then we added decorations and later the fidget spinner. That worked very well for us, so that we knew that the pump worked well and that the functional aspects of our fountain would work before we added details.
Everything worked out in the end, but we faced some design challenges along the way. The first one was that the flow rate of our pump was too high. We solved this with first a clamp and then a splitter to lower the water pressure so our fountain wouldn't splash. Our second design challenge was the fish on the fidget spinner. This caused friction with the walls on the tank, so the fidget spinner didn't spin as well, so we had to end up taking them off.
But it's not my fault. I think we estimated a competition to I was surprised that crafts
All right, to show the state of our work. This is cool.
Yeah, that was yours.
And